Hello, the team members are Andrew, Jack, Emma, and Maggie. Our client is Kennametal, and our project is about PVD insert coating uniformity. Kennametal is an American supplier of tooling pieces that are used for metal cutting and service a wide variety of industries. Coating is a key aspect of cutting-edge performance. One coating process they use is physical vapor deposition, PVD. In this process, inserts are loaded onto rods, a collection of rods compose a spindle, and 10 spindles make a carousel. There is variability in the coating thickness between different types of inserts and across batches. Thickness measurements cannot be performed without destruction, so currently thickness at the cutting edge is unknown, and the product may underperform as a result. To approach our problem, we chose to conduct a DOE and follow the steps as outlined here.
After considering many potential factors, we chose to study two product-related factors, the insert size and nose radius, based on insight from our Kennametal team and screening of past data. We identified 3 levels at which each of our factors exist, and we intended to follow a 2-factor, 3-level experiment design, which will result in 9 treatments in our design space. However, due to unavailable insert combinations, we were forced to exclude 2 treatments from our study, leaving 7 combinations. We chose to conduct 3 replications of our experiment in total. The experiment was designed around the PVD machine's existing carousel layout. The spindles in the carousel, which are characterized based on the insert size that they hold, were laid out in trios. We placed our treatments, the test inserts, symmetrically on the rods of our middle spindles. Once the PVD machine was run and our inserts were coated, 10 scaled measurements of the thickness were taken along the inserts. In this DOE, we instituted many process controls to try and avoid experimental error in the impact of noise factors. However, due to the complexity of the process, possible errors were considered an undeniable risk.
The next step after designing the experiment and having it be run was to deal with the data we got. And we mainly did this in 4 ways. One that's not pictured is hypothesis testing. One is gradient, another is coefficient of variation, and in R, we created a CART model to classify our inserts. To the right, you see some visualizations of our data and what we've done.
The main impact is that we've laid the groundwork for future designed experiments. This will offer insight into the physical vapor deposition process and lead to the optimization of production batches. We've also proved that our factors of nose radius and insert size have a significant effect on thickness variability, so that Kennametal can take action to decrease this variability moving forward. Finally, we've created a model to predict thickness on a given insert given our factors. Thank you all for listening.